Hello everyone, welcome to Module 8. In Module 8 we're going to learn how to create scripts using custom classes. Classes are a way of organizing functions and data, and there's a lot of different things you can do with a class or ways you can work with a class that'll help that organization. But in this module we'll look at the important ones that you should know about, not only for working with Python but in other languages as well. To get started, let's consider how classes work from the perspective of the three basic programming components that you work with. Those are statements, functions, and classes. Now, there are several different types of statements, but three common statements are data statements, processing statements, and conditional statements. You've been working with these now for a few months. A data statement is just declaring a variable and setting it. Like in listing 1, you can see that I'm setting the value 123 to the variable data integer. A conditional statement would be an if statement. If it's true that the data integer is equal to 123, perform some type of action. The action that it performs, in this case taking 123, adding 4 to it to come out to 127, and then adding that value to the variable. That's a processing statement. And the last statement is a input-output statement. You're actually outputting the result of that using the print function. So these are just common statements. And the way you can organize your common statements are to put them in a script file. That's one way to do it. But once the script file starts becoming more and more complex, you need other tools, and that's where functions come in. So statements can be organized into functions, and this is actually quite handy because you can write a function, and if you do it well, you can write it once and use it many times in the same program, or you can copy and paste it and put it into a different program. To do this, you wrap the statements inside of a function. So here in listing 2, I have an example of the organized statements function, and the same statements as in listing 1 are inside this function now. Now functions can also be organized. They can be organized into classes. So if you're a programmer and you think that you're going to want to use the functions that you write in other programs, so you write it once and use it many times, it really makes sense to organize things into classes. Now you could just use functions, as some programmers do. They just only use functions inside the module. They don't use classes. But this is another tool for organizing your code. So you could have a class that organizes functions and functions that organize statements. Now data and functions in a class will be called different names. Variables and constants may be referred to as fields, attributes, or properties. I'll distinguish the difference here in just a bit. Functions, on the other hand, are known as methods. And of course, a program that you work with can have many statements and many functions and many classes. It really all depends on how complex the program is. And using functions to organize your statements and classes to organize your functions make working with complex programs much easier. Makes it easier to manage. In this next example, this listing 4 here I have, you can see that I've got the statements, and I've got the functions, and I've got the classes all in one script. And it works just fine. When I go ahead and run the code, it will print out the result of 127 because I've added 4 together in all occasions. The big difference here is this. Statements will immediately run as soon as the script starts to run. So it'll start going through, when the script starts to run, it'll start going through the code from top to bottom. When it gets to the statements, they will immediately run those statements. There are 4 statements there, all 4 will run. The rest are comments. But when it gets to a function or a class, it loads that code into memory, but doesn't actually run it yet. In order for you to run it, you have to call it. You call the function, and that'll run the code inside the function, or you can call the function inside the class by putting in the class name dot the name of the function. Remember that functions inside of class are known as methods. So to call the method, I put the class name, a dot, and the name of the method. Actually pretty simple, right? Now classes can be focused on a particular task, such as storing data, managing data, or processing data, or even interacting with other software humans, the interaction piece, the input-output. The focus of the class determines what type of class it is: a data class, a processing class, a input-output class, interaction. And developers can decide what type of class they're going to make. Now, the type of class is not determined by any setting. It's just what kind of code you put in the class. So let's say I create a class for processing data to and from a file. I might give it a name like File Manager. I could also create a different class that was all about managing customer data. I might name it something like Customer. The File Manager class would be about performing actions, while the Customer class would be about organizing the data. So the File Manager, it does still have some data in it, but its job is really to process things, process data into the file, process data out of the file into your program. The Customer class, on the other hand, is all about storing and managing data. So that's what I mean by just kind of the type of class that you're working with. Classes have kind of a standard pattern to how the code gets typed into it. In a typical class, you'll have fields, constructors, properties, and methods. That's a general pattern that you see throughout the industry. Let's start off with the first one, fields. Fields are data members of a class. You create them by defining a variable or constant. In this next listing, you can see that I have 3 constants identified in a class called file info. The first one is the file folder constant. It's a constant because it's an uppercase. In Python, there's no way to designate that a variable is used as a constant other than making it uppercase and then asking people to respect that. The function I'm using to set the file folder is a kind of an interesting one, especially since we've been working with files for right now, and you just got off a module where you were doing some research on files. This is the current working directory function. It tells you which directory you are currently focused on when you run your program. I'll come back to that in just a minute. Anyway, I also have the file name and the file path. And the file path is a combination of which folder you're currently working out of and, of course, the file name. Now, when this script runs, it'll load everything into memory inside the class, but it won't do anything with it until you actually try to use it. In this case, I'm trying to open up the file. Now, if the file exists, it'll open it, but I don't expect the file to exist because I didn't create it. And so it's going to cause an error. It'll be a file not found error. And by now, since the last module, you were also researching how to work with exception handling. You recognize this type of error. And I'll make an error message, a custom error message. Now, because I have this class that actually has information, it's managing data, right? It doesn't actually perform any action, it's just data about the file. I can use that class to create a nice looking error message, something that actually makes sense. As you know, some of the built-in error messages are a little confusing, right? In this case, mine says, reading the data from that file, there's a long path, the data file cannot be found. Please check that program data.txt file exists in that folder. Now, I'm running this out of PyCharm, and this first figure, this next figure, I'm running it in a terminal window. And you probably noticed, as you've experienced before, that the path is very different. That's because the current working directory is different. In PyCharm, the current working directory is focused on the folder that my script file is in. If I open a terminal window, the current working directory is the one that I am currently in that terminal window. In this example here, the current working directory I'm running my code out of is the _Python class on my C drive. And so when the message comes up, it's contextual, which is a lot easier to troubleshoot, right? You know exactly where it's looking for that file. So by putting this together, it just makes the code easier to work with, also easier to use. The program itself is a little bit easier to use, a little bit more descriptive. Let's give this script a try. In Lab 8.1, what I want you to do is I want you to go and try typing in the code from that fifth listing there. Now, if you have a problem, you can always copy and paste it and give it a shot. That's fine. But I'd recommend trying it out. Test the code in PyCharm and test it in a terminal window just to see the difference in the current working directory. Just make a note of that. So if you would, go ahead and pause the video. And after you get it done, you're working with it, come back and I'll talk about it a little further. See you in a few minutes. Okay, welcome back. This is that file that you just typed out. And you can see that if I run it, it runs as expected and it gives me the message down here that I can't find the file in this directory. Now this directory is where this file is running from. So this is that file. If I right click on it in PyCharm and open it in Explorer, it takes me to that folder. So what's happening is that PyCharm is running it from this folder. Now if I open up a command window and I try to run that file, the folder I'm currently focused on is this one, users admin. And so that's the context. That is the current working directory. And this is an issue that many of you have wondered about. Now, I made a previous video on this, but it is kind of good to know. And you can see that the current working directory is the default, even if I don't specify. But you know, because I put that in my error handling, it's much easier to figure out what's going on. If I were to navigate to that folder, change directory, and I'm navigating over to this folder. Now that I'm in that folder, if I run that program, so I'm running Python exe in that file. Of course, in this case, I don't need the whole path, but even if I do, run it like this. The error message matches what we see in PyCharm because it's running from the context of that folder. So that now is a match for what we see in PyCharm. Anyway, getting back to this code, you can see that this class is all about storing data, and the data can be useful in our program for all kinds of things. We'll look at another example here of dealing with personal data in the next video. I'll see you there.